computer. All right, so the last class today, we are doing 5C today. So what have we done so far? 5A, we introduced statistics. So knowing about what population, sample statistics, population parameters. Those are things that we had in the first section. We also had, what was it, experiment versus observational study. Knowing the difference between those. If it's an observational study that happens to line itself up like an experiment, we call that thing a retrospective study. So knowing that there's a control and variable group. Single and double blind studies were also in there. So knowing what a single blind study is, knowing what a double blind study is, those were all in 5A. The next chapter, 5B, was about determining whether a study is credible or believable. And so there were like 8 different criteria that they talk about on there. And so that was 5B. And today we are in 5C. We're going to do a few graphs. We're going to do a few bar charts, pie graphs, and histograms. We're going to do a scatter plot as well. So that is kind of what's happening. Next class, we are going to take a test. There's a test, there's a quiz, and there is a research project that is due next class. Are there any questions where we're at, what we've done, anything? Any questions over what anything we've done? Any questions about where we're at or what's expected? Okay. All right, so we will start this one. This one, there's a few questions I could probably plug in, a few quizzes, but a lot of the stuff here, it's really hard. It's all tables and graphs and things of that nature. So we will work through these together, but these are, I don't know, the difficult problems to put in here. So I need some cooperation somehow. But this is, what is this, number 13, make frequency, I can't even speak. Make frequency tables for the following data sets, include columns for relative frequency and cumulative frequency. And so we are going to make a frequency table. So I'm going to have a column that says scores. I'm going to have a frequency column. I'm going to have a relative frequency, and I should have a cumulative frequency. So there are a few ways to fill this out. If you wanted, you could probably jump to the totals. But if I'm looking here, how many A's do I have? What's the frequency on the A's?
6.
Yeah, I got 6 A's. How many B's do I have?
6.
Yeah. How many C's?
10.
There should be 10 of them. D's are what?
5.
5, and then we get
3.
3. And if I add all these up, what do they tell me my total is?
30.
It should be 30 students. If we add these up, we can always double check it. 12 and 10 will make what? 22 plus 5 more, 27 plus 3 will give me 30. So I think if we added these all up, it should equal this 30. This 30 students total is what we should have. What about relative frequency? We talked about this when we talked about probabilities. This is like a probability. So what should all these relative frequencies sum up to? Do you remember this?
100%.
100%, yeah. But when we talk about probabilities, we don't use that percent. We use it as the decimal. So it should be 1. So it should be 30. I think you'll get 30 out of 30 if you add it one way. This should be giving us 1. If we do relative frequency here, what's my relative frequency for the A's? So this was like the number of events over the total possible number of outcomes. So if I'm getting an A 6 times, that's 6 times out of how many?
6 out of 30.
Yeah, 6 out of 30. So relative frequency, basically, what are we doing? 1 out of 5. I'm gonna also think. I think I'm gonna put a decimal there. Ooh. And I replaced the batteries on my calculator. Yesterday was a momentous occasion. I had to replace the batteries. 6 out of 30. Guess what this one is? It's also 6 out of 30. Woo! Way to be electrifying here, right? And so we're taking each of these and we're basically what? Dividing them by the total number, which is 30. So here I believe I have 10 out of 30. This should be the 1/3. If I'm doing a decimal approximation, it's 0.3 repeating. I think if I go 2 spaces, it works here. The other thing, this is 5 out of 30. This is the 1 out of 6. If I plug that in my calculator, I believe I get 0.16 repeating. I guess I could go 0.17 if I round it. The other thing is this is 3 out of 30. I believe this is 1/10, which is what, 0.1. So you might have noticed on the left here, I kept them as the unreduced version, because if I want to add all these up, come on, jar. If I want to add all these, not that last one, if I want to add all those up to sum it, it is easier to add things that have a common denominator. We keep the common denominator of 30. We're going to add 6, 6, 10, 5, and 3. We already added those. That's 30. 30 out of 30, that should give me the 1 that I'm talking about. So if I sum up my fractions, it should sum up to 1. I might get like the same number over itself, like 30 over 30 is what you should be getting, something like that. But this should sum up to 1. This over here should also sum up to 1. Sometimes, depending how you round things, it might be like 0.99. If I rounded this to like 0.16 or something, it might be a little bit off, but it should be like right there within like 0.01 or something of it, probably. 0.2 plus, I think this will work because I rounded this one up and I rounded this one vice versa. I rounded this one up and I rounded this one down, right? And so I think if we add these together, I think it comes out exactly to 1. All right. The last column they want us to do here. Do you remember what cumulative frequency is? So remember, I think maybe the word to think is like these are going to accumulate. So in this first one, how many grades do I have?
6.
Yeah, there's 6 here. And if I go to the second column, how many grades am I going to put here?
12.
12. So each time I'm adding, right? I got 6 A's, I have 6 grades. I add 6 B's, I have 12 grades total. I add what, 10 C's, I'm going to have
22.
22. And then I think I have to add 5, should get me to 27. Add 3, that should be getting me to 30. And then I'm at my totals. So something maybe to take away from this, and I think I probably mentioned it in the notes, but you might notice like those things repeat. You should get this total repeating like the line before. So your cumulative frequency and your frequency should be the total number of students in the class, basically, right? That should add up to the 30 students. This one should add up to 1 or probability of 1. One of these things is guaranteed to happen, basically is what this is telling me. They are mowing early this morning. Are there any questions about uh, this table? Do you think this is something that's doable?
Yeah.
All right. Ooh, that's not what I do. I want to clear my annotations. All right. Is this variable? Is this quantitative or qualitative? How are they giving us grades?
Is it qualitative?
Yeah, that would be qualitative. If they're giving you a letter, that's qualitative. If they're giving you a number grade, that should be quantitative. Oof. Ooh. All right. Now we're doing that qualitative, quantitative. The eye color of students in the class. So if I say red, orange, green, blue, indigo, violet, one of those things, that should definitely be please be a big green. There we go. There was like one person that kept on answering opposite, and I think they were just maybe trying to be jokesters or something. I don't know what they did. Qualitative, just to probably confuse you more. If I talk about the eye color of students, if I'm saying something like red, orange, green, blue, that is qualitative, right? And this is what they mean in this problem. But there are ways to usually express the same variable qualitatively and quantitatively. So if I tell you red, orange, green, whatever, but that's a color, but I could also give you color based on wavelength, right? Because colors are just wavelength, and it depends upon like how many nanometers. I think it's like 600 nanometers is the red light, and I believe it's red is the highest light. I believe it goes down from there. I think blue's like 300 or something. So there are different ways that they could probably tell you color. But when I say color, they typically mean red, orange, yellow, green. They're not asking for wavelength here. If they were asking for the wavelength of the light or something like that, that would be another way to kind of ask the same question, but ask for the quantitative part of it, I guess, right? When they're giving us categories, that would be qualitative. When they're giving us numbers, that would be quantitative. So here, if they're giving us, what was it, a price of a house? Price of a house is going to be quantitative. We can do things like put it on a scale. We can crunch it like a number, right? Sometimes they can give you numbers as categories or qualitative, but it's a bit weird. I don't think they do it in this book. But if we can take an average, if we can do like operations on it, like a normal number, it is quantitative. The annual salaries, we can take an average annual salary. We can do things like that with it. Oh man, my hand is itching like crazy. Okay, that is quantitative. Yep. Most populous countries. Okay, so they give us the 5 most populous countries in this table. They want us to make a bar graph for this data. And they want us to do it in descending order, which is the same order, if you notice the population, that's the same order they have it here. These populations are descending. Whew. And so we want to do a bar graph. I think maybe if I do this, it gives me a little more room. All right, so there are a few things that we need to do on our bar graph. So our bar graph is born. The first thing we need to do is give it a name. What is this called? Populations of the world. I don't know. Something along those lines, right? So what should go on my y-axis over here?
The population.
This should be the population. And probably something also put here. I'm gonna like put population in millions. That way I don't have to go too far. So over on the left is my population, and on the bottom on my x-axis is going to be what?
The country.
The countries. All right, so now I have to number this thing. I believe this is 5, 10. I have about 15 lines. If I look here, I think I need to go at least to 1400. I think it might just be easier to do 1500. So if I have 1500 and I'm dividing that by what? I think I said I had 15 lines. I think each one of these lines should be 100, is what I'm saying. So we take how far we have to go, we take the number of lines, and we divide by how far we need to go by the number of lines. That should give you your scaling, or pretty close to what you need. I guess I could have done 1400 divided by 15, but I'm being kind of lazy. Each one of these should be 100. Does this make, hold on, let me see if this makes it a little better. That's a little bit better, I feel like. Let me rearrange things around a little bit. So each one of those should be 100. This one I believe is 1,000. Does it do it right if I do it this way? I hopefully, let's see if this lines up. Oh, it's lining up pretty good. All right. This is what I planned on. It didn't work so smoothly in my other class. The preview is different from like what it shows you on the other one. It's kind of annoying. This is 1,000, 900, 800, 700, 600. 500 is starting to get off. All right. Hold on.
You're just gonna turn off your AC real quick, and we'll be back in a few hours to work on it.
It's off.
It's off? Okay, then we're good.
I got AC issues. Okay. Where was I at? 500. I was right here. 400, 300, 200. All right. And this one is chill. What is this? 1,400, 1,300, 1,200, and what is this? 1,100. Okay, and then down here, so those are my populations. So down here, I still need to put my countries. Here we go. I want to do China, India, China. I guess I'm going to go 3 bars wide. I think I can do that. Hopefully. India, 3 bars wide. US, and 1, 2. I'm going to abbreviate Indonesia, and I have Brazil. Three, skip 1, 3, skip 1, 1, 2, 3, skip 1. This one needs to come over right there. 1, 2, 3, skip 1, 1, 2, 3. All right, I think that'll work. All right, so some things that you need on your bar graph, you need a title, you need to label your axes, you need to number your axes correctly, and then the last thing that we're going to do is draw our bars. So China is, let's do some blue bars. China is where? At 1374. So this would be 1300, this would be 1400. 1350 is in the middle, 1374 is a little bit more towards the 1400. So I know these things aren't going to be exact, you're doing them by hand, but they should be pretty close, right? Just getting it within the sort of ballpark. India is 1267, so that should be between, where am I going, 12 and 13? And I'm going about halfways in between, maybe a little bit more than halfways. So that represents India. The next one is the US. We are at 321. So somewhere right about in here. The next thing is Indonesia. They are at 258. So that's between, about halfways between 200 and 300. I think it should be right about there. And the last one is Brazil, is right a little bit over 200. It's at 206. So it should be right in there. Okay. So draw the bar, fill in the bar. Hopefully, if you want to make a pretty graph, your bars should be probably all, excuse me, equal width. Are there any questions about this, about how to make a bar graph? I don't know if the book, I can't remember what the book says. But when we do a bar graph versus when we do a histogram, you might notice the bars here aren't touching. They are separate groups. China is separate from India, separate from the US. When we do a histogram, you might notice that they start touching. So when we do a histogram, this is going to be numerical scale. This thing will be a numerical scale. This is basically what the difference in a histogram is. So when we do a bar, I can't speak. When we do a bar chart, these are groups. This is China, this is India, this is US. These are qualitative variables. When we do a histogram, these are going to be quantitative. Any questions on this? Does this seem like something that should be doable? Do you feel like you can do a bar chart, bar graph? Okay. All right. Cell phone subscriptions. So the following table shows the number of cell phone subscriptions in millions in the US throughout the years. They want us to construct a time series graph for the data. Does the graph show straight line growth, linear growth, or is the growth faster than linear? The number of subscriptions can be larger than the population because you can have more than one phone, right? Basically is what it's saying. So here's the year. Here's the number of subscribers in millions that we have. Personal and business cell phone, which is a very fancy way to say they got a burner phone, probably. I could do this by hand. This is sort of like my X variable. This is my Y variable. Oh, why'd you jump over? I could jump over to the right to 1997. I could jump up to 1990. I could jump up to 55. I could do that. That's not what I want to do. They want us to construct a time series graph. Basically, what they're asking for is a scatter plot here. And so what I really want to do with this thing, and you should be able to do it by hand, But like I also think it like might come into handy to use some technology. So if you want to use technology to graph this thing, you can do that. If you want to graph this thing by hand, you can do that as well. But I want to do a table. I want to start with the year 97, and it's going to go up to 2015, 1997, and I go 1999, and then 21, and I'm going to go up to 2015, skipping 2 years each time. And so I put in my X variables. I want to put in my Y variables, which look like 55 and 86 and 128 and 159 and 208 and 255. And this is part of the reason why I wanted to do it too. See if y'all can, I think like using technology is important. And we have enough examples where we're doing stuff by hand. I feel like doing one of them is what the next one's 316 and 336 and 378. 336 and 378. Does that look correct? I think that looks right. Okay, so I got all these in, and I look at my graph and I see nothing. So what is happening on my graph? Why don't I see these?
Because the X is too far out.
Yeah, the X is too far out. So I need to adjust my windows. Well, what I need to do here. So there are ways to do this. If you do this in your TI, there's ways to adjust the window in the TI. But whatever technology you're using, you're probably going to have to adjust your window. So I want to go from 1997. I think I'm going to start maybe at like 1996. And I want to go to 2015, so maybe like 2016. Ooh. And so my X was too far out. You might also notice I need to go from what, 55 to 378 in my Y axis. So I need to go from, probably start with 0 so we have the axis, or maybe even go -1 so we get a little bit of that. And I need to go to 378, which is pretty close to 400, I think might get us there. It is squished up in there. All right. So now I see this thing. And what questions are they asking? Time. They want a time series graph for this data. So if they want a scatter plot, this is a scatter plot. If they want a line graph, you can do that on Desmos. There it is, lines. You can add lines on Desmos. This is a line graph. All right, let's go back at that. This is a scatter plot. We draw a line between each dot. Oh, come on. It is a line graph. Scatter plot, line graph, scatter plot, line graph. Okay. So they want to look at this thing, or they want to look at this thing. This is our time series plot. And I think the question that they asked, does this graph show straight line growth or linear growth? Does this look like it's growing like a line is what they're asking. Can you draw a line of best fit on this thing? Would it
Yes.
look like that? Yeah, it looks approximately linear, right? I could draw like a sort of linear line and get it probably like in the middle here somewhere. That's probably not exactly the line of best fit. But I could draw a line. This thing looks linear. What they're saying is I don't have a bunch of dots like coming over here or something like that, right? They're not like falling down or doing something crazy, going at a different pattern, right? They are pretty close to that line for the most part, right? All these dots fall within like a reasonable distance of this line. So this is something, and it's got a big fancy word. They call this linear regression. It's called finding the line of best fit. It's called linear regression. It's just a big fancy word for saying I want to find the line that fits it best. So we can do linear regression. Not everything grows in a linear sort of fashion. So we could also do, if they're doing, if it looks more like this, right, that would be like exponential growth. You can do exponential regression. So what would be like viruses and populations and things of that sort that grow in a linear fashion. We can do in exponential, or we can do it in sort of logarithmic is the other inverse function of that. So we might be doing regression with other functions. Well, we won't be. I think the only thing they ask is for lines in this class. But it is out there, right, is what I'm trying to say. You could be doing regression with other lines, with other functions, I should say, not other lines. There are other functions. We can do square regression if it looks like a quadratic. So remember, quadratics look like this, but they're probably only going to focus on like half that quadratic. So if it looks like half a quadratic or something, it might be just like half that parabola. If it has that sort of growth, it might be a quadratic regression. But this, it looks fairly linear. And let me get this back on there. So another thing, and this is probably going to be a lot of information in a short time, but we'll get it. Let me get this maybe a little better, get my point across. Let me get this line here and here. So let's pretend like this is my line of best fit. Let's go right in, I don't know, here. So what you might notice is, let me get a different color here. When we talk about the line of best fit, we want the thing that is closest to all the points. So if we look at the distance here and we look at the distance here, I believe we subtract, I don't remember what order we subtract things in, to be honest. But when we subtract the point from the line, if we did it here, we would get a positive result. If we subtracted it here, I believe we would get a negative result. And so what we call these, the distance from the point to the line, those things are called residuals. And we want the one that is closest, so we don't really care whether it's positive or negative. So we do this little trick where we square things, because when you square things, positive things become positive and negative things become also positive. So we have a bunch of positive results and we add them together and we try to get the one that is the least. So you might also hear this line called the least squares line. And that just means that we're taking those residuals, we're squaring them because they could be positive or negative and we don't care. We just want to know how far it is. So one of the tricks to get rid of negatives is to square things. When you square a negative, it becomes positive, right? And when you square a positive, it's still positive. So least squares line is another word, linear regression, line of best fit. These are all things that are really, they're all kind of saying the same thing in different ways. Any questions about this? I would say it's approximately linear. Or is it faster than linear? Nah, I think it's pretty close to linear. Questions about this? Does this seem like something that's doable? We're basically plotting the X or plotting the Y. If you're doing it by hand, you're gonna have to divide this and make sure you get enough numbers in here like we did in that previous problem. But that's it. We're basically plotting these on the X and the Y, on the Cartesian coordinates. All right, we did that. All right, so the next one, what are we doing here? The following table gives the percentage of electrical energy generated in the U.S. from various sources. Display the data as both a bar graph and a pie chart. Then write a short paragraph discussing the pros and cons of each display in terms of interpretation. All right, so I know when I do this next page, it's going to throw it off. I really need. Do it here. All right, so I want to do a bar chart and I want to do a pie graph. If I do this, I can have those numbers and I can have my thingy here. Coal is 33, natural gas is 33, nuclear is 20, renewables that are non-hydro are 7%, hydropower is 6%, and they always have that one that's just like, oh, this is everything else and it doesn't account for hardly anything, so we're just going to call it other, and it's like 1%. So what are we doing? We're doing U.S. electrical by the what? Energy source. So this should be U.S. electricity by energy source. Something along those lines. Electricity by source. What am I going to put on my y-axis?
Percent.
Yeah, so this is the percent generated. And here I'm going to go down to what? The X is the source that generated it. So in my percents, what do I need? I need something that I believe. Oh, what is it doing? Did it freeze? It froze. Come on. Something froze. I can't click on nothing. Where are you at, Zoom? There we go. Oh man, Zoom is acting like it's like not wanting to work or something. Okay. The percent, I believe it went as high as 33. So this is 5, 10. I believe we got 15. If we do them by 1, we're not going to get there. If we do them by 2, I think we'll get there. Is that right? 1, 2, 3, 4, 5, 10, 15. That would give us 30. We're going to have to do them by bigger than 2, huh? 4s. I guess we could do them by 3s. Okay, so we do them by 3s. That would be what? 3, 6, 9, 12. 3 by 15. That would give me 245, I believe, right? Oh, I didn't make this bigger. I can't because it's frozen. My browser is completely frozen. What is it doing? Maybe if I stop sharing. Let's try this again. I think like Zoom is just freaking out with the share or something. So let's try this again. And it undid all my annotations, didn't it? All right. Let's read this again. So U.S. energy by, now it's completely frozen. Jesus, man. U.S. energy by source. I can't even spell source. This is percent over here. This would be the source. I'm going to take this bar, move it around so it's not in my way. Oh man, it is like lagging. I don't know what is happening. Come on. This problem's not supposed to take that long. It is like completely frozen, man. Well, that's working. Let's see. Can you still? Okay. I think I can still do this. It is just like, it is acting super glitchy. And I need. All right, so do I have, oh no, I hadn't logged into that. Okay, so let's see if I can get back to this page or if it's gonna glitch. So I think if I take a picture of this, I can have these numbers and I won't have to flip back and forth. So let me take a picture of that right quick. So I would take a picture of this with your phone or something. That's what I'm doing. Get these numbers down. Although I think you have them because you're on that. You're logged in to the quizzes. All right, so let's get this thing done right quick. I have coal, I have natural gas. They are both at 33%. Oh, I need a number on my axis. That's where I was at. So I believe this gives me 45. This would give me what, 42 here. This would give me 38. Did I do that right? No, 39 minus 3 would be 36. That's already getting off there. 42 and 39. This would be what? 36 and 33. This would be what? 30 and 27. What am I? 24 and what? 21. And 18 and 15. Almost there. This is what? 12 and 9. And 6 and 3 would be that first line. I swear I had these to where they were spaced where we just set it up exactly if I hit enter. Um, is there? Oh no. We have these numbers, and then we're looking at what are they giving us? Coal and natural gas. So I'm doing coal. I'm doing two. I think I'm going to do two wide. Natural gas is here. If I do this too wide, I skip one that's too wide. I'm going to skip one. Right here, I got coal. I got natural gas. I have nuclear power. I have, what's next? Renewable was the next one. Renewable, not hydro is what it says. And then the next one we have is renewable hydropower. So this is these two. This one would be this one. I think I can go back. This is where it starts, I think. Hydro, and then these two would be that, and then this one right here would be other, I believe. Is that where I'm at now? Yeah, other. So I know, I think this is the second bar graph we've done, huh? Oh, let's do it purple. All right, so the first two are at 33. So if I'm looking here at coal, oh, I don't want the one that's empty. I want the one that's solid. There we go. I want to start here at coal. I'm going to go too wide on these, I think. And I'm going to go up to, what is this, 33%. Natural gas, I want 33%. For nuclear energy, it is 20%. So here's 18, 19, 20, and then 21. So I've got to go 18 is here, 19's here, 20 is about right in here, right below 21. That's my nuclear power. Here. Renewable is what, 7? 3, that's 6. Right here, a little bit above the 6 would be 7. Hydropower is 6%. So right here at the 6. The other is at, where are we at? 1%, that's right. So it just barely comes up. All right, so that is our bar chart. We have to do a pie graph. I think the easiest way is to probably start off with the larger things. So if they're at 33%, what's a good way to think about 33%? How much is that?
1/3.
It's about 1/3, right? 33.333 is 1/3. So if you use the fact that that's about 1/3, we divide our circle up into thirds. The thing that I'm thinking is like, it looks like a peace sign, right? So if you divide your circle up into thirds, I think that will get you pretty close for the coal and for the natural gas. So coal, and maybe I'll even put the percent in there. Coal is 33%. Natural gas is 33%. Nuclear is at what, 20%? So here, I think you might have to do maybe a little bit of figuring. We could have done it with the other one too, right? We could have done, if we do 33% of 360 would be a full triangle. If you really wanted to do that, I guess you could do that. It's not the prettiest thing, but that should tell me it's 118.8 degrees. If I do 20 by 360, so if I want to get some degree measurements, I can do the percent times 360 degrees, which is the full circle. That would give me 72 degrees. So I know you're doing this by hand. It's like, what is 72 degrees? It's not a right angle. I guess that much, right? If you think about a clock, between each two numbers, I think is 30 degrees. So if you go between two numbers, that's 60 degrees. So it's between 2 and 3 numbers on a clock, I guess, is one way to look at it. Oh, you're going to kind of guesstimate these things a little bit. So 20%, and then the next one is 6%, 7%. Sorry. The other one is 6%. And the last one is like 1%. Which gives me like 3.6 degrees or something really small. 0.06 times 360 gives me 21.6. So this is about 21 degrees. This is about times 360 is what, 25.2. So these two are really close. These two should look about the same size. This one should look about a little over double that thing. So I think if I go about halfways and go a little bit further, maybe. It's not quite a right angle, but it is pretty close to a right angle. Where is that? Like right in there, maybe? I think that's pretty good. Like I said, it doesn't have to be exact. It just has to be pretty close. These two I'm getting divided up. And then I'll have another little sliver like right in here. So I know it's not the straightest. It should be like all going towards the center. These aren't exactly going towards the center, obviously. But the important thing is that they're pretty close. I need to put some labels in here. And I really should have put a label or a title overall. U.S. energy consumption or production by, it wouldn't be the other way around, production by source. Something along the lines. It could be the same title that you have over here. It's the same graph. It's just a different format. So coal, natural gas was 33. The next one was nuclear power was at 20%. These you might notice, oh crud, I can't start writing stuff in here. So I got to figure out another place to put the stuff. So I'm going to say renewable. Non-hydro, just to abbreviate things a little bit. This is at, what was it, 7%. And so I'm going to put it on the outside probably. And then I got to draw my little arrow and say, here, it's going in here. So I should draw some sort of arrow. I want to do a different color than purple. Let's do red since my font's in red. So I want to draw that's going in there, that's going in there, and let's do one over here maybe. So that one was not renewable, non-hydro, and then now we have hydropower is 6%. And the last one, it just says other, that is 1%. Okay. They want us to draw a bar chart. They want us to draw a pie graph. And then they ask us, which one is better? Like which one would you use if you had to do a presentation? I guess is my question. If we're doing a presentation over the way that the US produces its energy, which one's your preferred one? Not necessarily which one's easier to make. You can do these in Excel, right? Excel will make most of this stuff for you if you go type it in Excel. It's pretty industry standard software. So I would definitely play around with Excel and try to do this stuff if you've never done it. But you can do most of this stuff in Excel. It will kind of do the work for you for the most part. And if you had to choose, are you going to do a bar graph or a pie chart?
A pie chart.
That's what I would do. Why would you do this? Why this one?
Because it shows the percentages more efficiently. You're able to see how much of each.
Yeah, because the keyword exactly, like the keyword that I would say to describe it is parts of a whole, right? You have a whole thing called all the energy produced in the US. This is going to show us parts of that whole. It's going to divide it into how it's produced. Into parts of it are produced with coal, parts of it are produced in natural gas. This, when we look at it, it gives us a lot better representation of like, hey, this is talking about one whole thing, right? When we look at it over here, how much does coal and natural gas take up? It's not super obvious in this chart, right? But we look at it over here, it's like, oh man, that's like 66%. That's like a good portion of that circle. So it is like very visually more appealing to what the actual information is saying, I think. And the key word there, like I said, would be like, it's the parts of a whole. Anytime you have parts of a whole, pie graphs are really like probably the way to go. It shows that it's a whole thing. Here, it's not quite as obvious. You could probably tell that coal and natural gas got more than the rest, but how much more? It's like it's not quite as obvious as looking at over here at the circle. Any questions about this one? I know it took us too long to probably get this thing up, but I don't know what to say. Sometimes technology works against you. Sometimes other people try to barge in. I don't know. Does this seem like something that should be doable? And like I said, these things don't have to be exact. If it was 25%, I would expect to see a right angle in there, probably, right? If it's a quarter of the circle, something like that. It's just got to be pretty close. I'm not expecting you to bring a compass along, or not a compass. A protractor would be the thing that you use to measure angles, huh? I'm not expecting you to bring your protractor along and like do that sort of thing, but you should have a pretty good like feel of like how big that thing should be, right? Like these should be about half the size of this thing. These should be about a third of the circle. Things like that would really, really help get you along. Okay, so this I need to shrink down. I'm going to clear my annotations. We don't have too many more problems. All right, and now we are doing this one. The following frequency table categorizes Nobel Prize winners and literature. Ooh, I think we're going to do a histogram now. Through 2016, by their ages at the time they received the award, display the data in a histogram and write a short paragraph explaining any noticeable trends or patterns. All right, so we want to do this as a histogram. So what am I putting on my y-axis, I guess is the first question. Oh, I want to make a little adjustment to this thing, actually. I don't want to do less than 50. I want these to be even. So I know this isn't what it says, but we're gonna go from 45 to 49, I think is what we want to do here. Just to make things even. So what's going on my y-axis? What's going on my x-axis? I guess is the question. This is age of Nobel Prize winners. I guess would be what I call it thing overall.
The
what's-
y-axis would be the number of winners, and then the x-axis would be the age.
Exactly. And so we have numbers of winners. I think we need to go from 0 probably, and we're going up to, it looks like the largest one is 20. We have 15 of them here. I think if we go by twos, we can get it. 2, 4, 6, 8, 10. That would give me up to 20 right here. Is this lining up? This one's lining up better, huh? 14. All right. 12, 10, 8, 6, 4, 2. All right. Are these lining up good enough? I think that's good enough, huh? Let me space these one over so it's a little closer to the line. There we go. 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. And my age. So how am I doing my age? So I believe the lowest I'm going is where? 45. So I think I'm gonna hit 45 right there. And I think I'm gonna skip one and go every other one, and I think I'll be able to make it. And let me put 45 right here. 45, and we gotta go to, the next thing I gotta go to is 50. The next one I gotta go to is 55. And then I gotta go to 60, and I gotta go 65. So each bin is going by 5s, you might notice. When we count, we're counting 45, we're counting 46, we're counting 47, we're counting 48, we're counting 49. So there are 5 numbers in here. There are 5 numbers in here. 50, we have to count 50, we have to count 51, 52, 53, and 54. So you might notice these are going every 5, 70. Let me expand this a little bit. Be that line, that would be a skip a line. This would be my 75 right here. I skip a line, this would be my 80 right in here. And this would be my 85 right in here. This would be my 90 right in here. So I believe we had 9 bins, I think is what this is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means I think we're gonna have 10 endpoints. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? 2, 4, 6, 8, 10. Should be 10 endpoints, I think. Let's see if I can move this up a little bit. 45 would be that line, 50 would be that line, 55. Make sure they're falling on the right line. This one might need a little adjusting this way and that way, maybe. I don't know. All right, so I said this earlier when we did that bar graph. I think I'm gonna do this in green. But between 45 and 50, So I know it says 49, but I'm going to go up to 50. Between 45 and 50, I have 9. So that would be right in between 8 and 10 would give me the 9. So I want to create this, and it's pretty much just like I did when I did a bar graph, but now I am doing numerical values down here. So I know I don't hit 50 here. I hit 50 on the next one. And I go from 50 to 54, which is really, I go up to 55. So it's going to like go up to the next number, but it's not actually containing the next number. The next interval is the one that contains the number. So this, where I'm looking here, this should give me 9. This next one should give me 10. The next one after that should give me 18. So now I'm coming up. I'm doing 18 here. So between 55 and I don't go to 50, I go to 50 or 60, I go to 59. So between 55 and 60 or 55, 59, I'm getting 18. And I mentioned it when we did the bar graph, but these things, they should be touching. These numbers, there's no space between the numbers, right? Is what it's kind of saying. We're going from 49 to 50 and there's no gap in between there. So there should not be any gap within your bars. Between 60 and 64, I think is what I'm doing, is 18. So I get 18 again here. I get 19 in this next one, which is right in here. So I know I said there's no gap. So maybe fix that a little bit. There shouldn't be any gap in between these things. It might be a little bit of gap because I'm doing it on a computer and it's not the neatest thing. But 70 and 74, I have 18, which is right here. I'm going to 18. I am going from 75 to 79. I'm going to 15. That would be between 14 and 16 here. Between 80 and 84, I have 4 here. Oh, come on. 1, 2, 3, 4. And then I have 2 in this last one. And did I mention in math, we don't get the Nobel Prize. Nobel Prizes are awarded for applications of sciences, I think is what it is, or applied sciences like statistics and chemistry and things of that nature. When you get to pure sciences like math, the mother of sciences, as they say, they don't give away the Nobel Prize. They have this thing called the Fields Medal. So the mathematical equivalent of the Nobel Prize would be the Fields Medal. So we look at this thing and they say, do you notice any noticeable patterns here? So what sort of noticeable patterns do you notice here?
I would say none.
What could you say about the age of Nobel Prize winners? Is there anybody like?
Oh, well, it's higher between the ages of 55 and 80.
Yeah, absolutely. Most people fall with right in here, with probably most people being like between what, 65 and 70. So there's a real emphasis on people that are between the age of 55 and what would you say? Was that 74? I think is even goes high. We have 18 here, right? We have 18. So most people are falling within 55 to 74 age range when they're getting the Nobel Prize. We look here, it starts dropping off pretty quick, right? You might even say between what, that and 80, I think. I think that's what you said, right? So most people are like right in this area. We notice here it starts dropping off pretty quickly. We notice here, this is probably actually lower and it probably has like more little things out here because we condensed this to like 45 to 49. It should have just been like less than 50. I don't like the way that they gave you this less than 50 bullshit. I don't know. They should give you like an even interval if they're making you draw a histogram. They should have figured it out. I don't know what to say. It's kind of, I don't like the way that they did it. That's why I corrected it. But this probably looks more accurately. It probably looks more like this where it stair steps down or something. So yeah, I think the trend that they want you to notice is that this looks kind of like what we might say is unimodal. It's got one sort of area that really comes up, right? And it goes down on both sides. And I think I might have talked about it, but if you have something that looks like this, it's got those long legs, or it's got a long leg going off of this way. It doesn't look too terribly skewed, is what we would say, right? If it's got a long leg coming off of it, we would say that skewed. This would be skewed to the left. This would be skewed to the right. And we hadn't talked about, oh, that's something we'll talk about. Mean, median, and mode. We didn't ever talk about that, man. I can't believe they don't make us talk about that. Mean, median, and mode. Have we talked about, do y'all know anything about these things? Y'all know what a mean is. If I take your grade and I average it, that is what the mean is. This is the arithmetic average is what they call this sometimes. All three of these things are what we consider, or what they call sometimes measures of central tendency. So if we want to talk about like the average of something, the average person, the average Nobel Prize winner, the average age of the Nobel Prize winner, since this is symmetric, this is telling me the mean is probably pretty close to the median. So the mean is like when you take all your numbers, you add them up and you divide by the total number of things, right? Just like you do with your grade. The median. So if I have 1, 2, 3, 5, 7, 8, 8, 9, something like that, and then I'm just going to throw in a crazy number, 10,000 or something crazy. Let's say this is what people scored on a test. Horrible grades, but there we go. I didn't say what the scale of the test was. Someone made 1,000 on it, so apparently it's a crazy test. But if I wanted to talk about the average of these scores, if I did a mean or arithmetic average, you might notice this 1,000 is really going to crank things up, right? It's just like if you're acing everything, right, and you suddenly get a 0, that 0 is going to really bring down your grade, right? It's not something you want to do. So when you have these things that are way high or they're way low, like a 0, we call those things outliers. And so when we take the mean, if we average this is what, 10,000, I don't know, 1, 2, 3, 10,000 plus 9 plus 8 plus 8 plus 7 plus 5 plus 3 plus 2 plus 2 plus 1. And there are 3, 6, 9, 10 things I'm dividing by. I'm getting like 1,000 for my average of these things. If I tell you 1,000, is that a good representation of these numbers? Probably not. So one thing we like to do is take this thing called the median, and basically what we do is we strike out lower, higher, lower, higher. We get in the middle. If we have two numbers, we have to average them. So I think we have 6 here is what the median of these would be. If we have an odd number of things, so let's do an odd number, maybe 2, 3, 4, 5, 7, 3, 6, 7. It's easier to take a median of an odd number. Basically, what we're doing, the same thing. We're doing marking out both high and low till we get to the middle number. The middle number here would be 3. That would be my median. And so one of the things we really like to do, and you'll probably hear this out in the world with like wealth inequality and things of that nature, right, is when we talk about things like income, if you talk about mean income, it's probably going to be a really high number because of the 1%ers. There's very few people that make a lot of money, right? And so when we talk about mean income of an area, it's not really a good representation of what the average person in that area is making. So quite often when you talk about income, we want this median income. And part of that reason is because the median is resistant to outliers, right? Is what we would say. This thing kind of resists these outliers. Whereas when we take the mean, we have to put those outliers in there and it really messes up our mean. One of the things when your population looks symmetric like this, when it's a normal sort of curve and it looks symmetric. So let me draw maybe a symmetric curve like right above this. So pretend like this is symmetric. Our mean is going to be equal to our median here. So when they are symmetric like this, this means our mean is going to be equal to our median. When they are like this, this means we have outliers that are low. I believe this means that our mean would be less than our median. So our mean and our median are going to be getting thrown off from each other. When we get this symmetry, they get really close to each other. And I think this would be the opposite way. This would make our mean higher than our median. We'd have a few outliers up here that we're really throwing off what the average person over here is doing. Mode, what is mode? Do y'all know that one? Mode is the most used one. So if I'm looking here, it would be the number 2. 2 is used 4 times. That's the most. So sometimes you'll hear mode. I feel like we use mean and median more, though, if I'm being honest. It really depends on what the experiment is and what you're measuring, I think. Are there any questions over anything? I think we're about time. All right, do you feel like you can do a histogram? There are some histograms on your quiz. Be able to do a bar chart, be able to do a histogram, be able to do a pie chart. Bar graph, pie chart. I always I'm mixing up bar graph and chart. Same difference. Any questions about this? Any questions about anything that you're expected to do? Anything? Any other thing that you want to complain or I don't know. Anything else? That's all I got for you today.
After Thursday's test, would that be the end of class?
That's the final day. That's the final day we're gonna meet. Yep.
Okay.
I'm basically getting stuff graded at this point. And I'm hoping to get stuff graded by the end of this week. I believe grades are due next week by the 19th or something. So definitely, that was another thing. And I think I told y'all, and y'all are pretty good for the most part, I think, but don't try to turn in late work. This is the last week. This is the last week that I'm probably going to accept work, right? I'm not trying to stick around and grade stuff for people. Getting turned in late. Part of it's I'm not trying to stick around. The other part's I can't stick around because grades are due, But yeah, don't turn in stuff late this week. Get stuff submitted by the test. So y'all got those 3 things, right? You have a test, you have a quiz, and you have research. If that's it, that's all I got for you.